Hey, hello, folks. How's it going? Thank you so much for joining this Serverless Office Hours today. This is August the 19th. I'm here. You're probably not recognizing me. My friends from the usual Serverless Office Hours I think they're enjoying some well-deserved rest, and this is why you're left with me. But fear not. We have a special episode today in store. We will be chatting about what makes a serverless workload actually tick and what it is Depot.Dev. So your build platform that is accelerating hundreds of thousands of builders around the world and not wasting time just sitting there idle. I am Giuseppe Battista. I'm a senior solutions architect. I usually work with startups, and today I'm bringing you a startup that is building a fantastic build platform so you can ship your containers to production much faster. I'm talking about, of course, Depot.Dev, and I will be bringing on Jacob to the stage in just a few seconds. So, folks, if you are if you're not used to this kind of format, in August we will be bringing in some I would say some startups that are actually building some really cool stuff. We have the chance to pick their brains, and today we will actually have the chance to have a look into something that maybe you're not used to. We're actually picking behind the scenes of actually how a serverless system actually works. And you guess what? There are a lot of serverless there are a lot of servers in a serverless system. So let me bring Jacob up to the stage, and we are going to start chatting about what makes Depot so special. Hey, Jacob, how's it going?
Going well.
Sounds great. And I know you've been on one of these shows before. You've been on Let's Build a Startup. I think today we're gonna focus a little bit more about what is it that helps you and your team actually enabling hundreds of thousands of builds to reach to production as quickly as possible. Maybe just a few words about yourself. You're the CTO of and co-founder of Depot.Dev, right?
Yeah, that is correct. Yeah, my co-founder and I started Depot 3 years ago now. Time flies, but yeah, we both knew each other from several companies before. Both worked as engineers, most recently as platform engineers, and yeah, kind of Depot was built out of our own shared pain with software builds being so slow and wanting a tool that could like help make that better.
Yeah, and I guess chat question for you. So, how long does normally a build of your serverless application actually take? And I'm talking maybe I'm thinking maybe about your Fargate containers or your Docker containers in general, and maybe even like packaging up your Lambda function or even packaging your front end that then you ship to S3 and serve through CloudFront. Just let us know. And maybe we can see how we can make it faster with Depot.Dev. I think that the first question is, what is it? What is the true risk in actually having build that take forever to build?
Yeah. So there, I would say, are different types. The most immediate one for us when we started was just the kind of annoyance and breaking of the flow, I guess, as a developer, right? Like you're working on an application, you want to open a PR, you want to ship it to production, whatever, and like there's a certain threshold at which like the build taking a long amount of time. I don't know. Maybe I'll get up and get some coffee. Maybe I'll go check Twitter. Like I don't know. Or just the equivalent of sitting and watching paint dry, right? Like I really want to know if this thing's going to succeed, but it's taking many minutes. I say like there's definitely that developer side. On the business side, like I have definitely felt something in production is broken, right? And like everything between me writing the fix and actually delivering it is affecting customers. And so like anything you can do to like to compact that build time down means faster fix. So yeah, I don't know.
Yeah, it's easier to get to the market and faster. If something is broken, it's easier maybe to establish that feedback loop, and maybe even during your development cycle. I guess that this is something. There is a Marcus Aurelius. He says, "I work in production. I get you, bro." Absolutely. I still remember, and again, showing my age here, when we were building this, say, large images for I think for ECS at the time, still running on EC2 instances, we had like this infinite Jenkins pipelines. They would never go green, and they would break for any sort of reason. Then maybe did all of the time to let's say the median time to fix was heavily impacted by how much iteration we would have to do, because again, maybe our observability wasn't up to spec, or our ability to actually fix the issue, especially if it had impacted production, wasn't really the best of our time. Maybe at 3 a.m. in the morning, right? So yeah, so that's quite challenging, and I guess that's kind of the problem that Depot.Dev actually solves. And this is presented to your end customers as a completely serverless platform. Like, how do your customers actually make use of Depot? And I saw a few tutorial on your webpage. Just I was thinking like maybe swapping the Docker keywords to Depot. That's really cool.
Yeah. So 3 years ago, we were particularly focused on container images and kind of started there. These days, we have expanded, so we integrate with CI providers like GitHub Actions, or build tools like Bazel or Maven or TurboRepo. And I think we built the tool that we wanted to use, and part of that was like, it's not realistic to rewrite all of your build pipelines and tooling and scripts and all from scratch. So one of the principles we've had throughout what we built is like integrate with the existing tools and the existing workflows. So yeah, I mean, whenever we want to, I'm happy to dive into like some code, a demo, but yeah, the ability to have whatever you're doing in Docker, but accelerate that with the Depot CLI without like entirely adopting a new tool. So
yeah, that's a very clever move, I think. And I guess I really would like to dive a little bit deeper onto what the Depot is. So I I would say, let's bring up your screen and let's see a demo of it in action. And then I guess what we can do is maybe talk a little bit more about the architecture behind it. There was a very interesting post that I read about you guys and how you're minimizing the time to boot up EC2 instances. So that'd be super interesting to dive a little bit deeper into. But without further ado, let's get our hands dirty.
Nice. Cool. Yeah. So Depot takes whatever you're building today, be that a container image, a GitHub Actions workflow, and makes that faster and more observable. So I think the main things to note are like better compute, better caching, and then like an idea of what is actually happening. For that, I have this repository here. This is the source code of the open source project Traffic, which is a web HTTP proxy. And we're just using this as kind of a demo application. But if I go here.
And this is written in Go, right?
This is written in Go, yes.
So like normally this is a compiled language. It normally takes a while to wrangle in all of the dependencies, do the compilation, do all of the I don't know, running through all of the tests. So it's a huge project, right?
Yeah. There are two things going on in here. One is a container image. So we have kind of a probably pretty familiar Docker file that we're building, and then a workflow in GitHub Actions that builds it. We also have some unit tests as well that are running. So kind of, your typical CI type of workflow.
So you have build you have builds and you have tests. What is there as well? Sorry, I was kind of distracted by the chat.
Yeah, builds for the container image and unit tests.
Okay.
Yeah.
Sounds great. So
Cool.
typical workflow. Let's
Typical
move on.
workflow. Yep. So in this typical workflow, we are through GitHub Actions calling a Docker build. If you're doing this today, then that Docker build is happening like in the GitHub Actions runner, right? So we're building and pushing the image somewhere else. But we're doing some other things too. In this case, we're building for both Intel and ARM CPU architectures. So this could be like important for, let's say I'm using Graviton in production, right? But I still want the AMD 64 image, say for a local workstation. This can be kind of slow in GitHub Actions too. There's something in here called QEMU that handles the like emulation required to build that.
And this is also what we call kind of a like matrix build, right? Because we are targeting different architectures. And so, for example, with the I think with Lambda, for example, right? When we are, if we were to choose the different type of runtimes running on x86 or on ARM, and maybe want to for some reason we want to build different kind of Lambda function. Maybe some of them have dependencies that are hard to migrate to ARM. This is what we would do, right? Or even, for example, if you want to compare the performance because you're doing some cost reduction exercise or cost optimization exercise, that's also something that I would recommend to actually do. Like, this is a build, a matrix build. It has various different configurations. You have various different targets. So this is why it's kind of multi-dimensional. Sorry to interrupt.
Yep. Nope. That makes total sense. Cool. So I have already pushed this commit that adopts a Depot for this particular step, just so that we can have this diff here to show kind of what this does. So we're taking our workflow that we're used to with a Docker build push action, and we are installing Depot and using the Depot build push action. So similar, like I was saying, we try to integrate with existing build tools. There's a Depot CLI that has a Depot build command similar to Docker build that accepts the exact same flags. So anywhere you're running a Docker build, you can run a Depot build. In this case, we also have a convenience action that matches Docker's. So if you're used to Docker's GitHub action, you can use Depot's equivalent GitHub action.
Ooh, that's very clever.
Yeah. So what this does, if I go look at the build, is you're going to have your workflow just like you're used to. And in here, you're going to have the logs just like you're used to. There's an interesting thing at the top, which is we are launching an AMD 64 machine and launching an ARM 64 machine. And we also have this like link. So I'm going to open up this link here. And so what's happening is instead of that build running in the GitHub Actions runner, like with the limited resources available there, we're actually turning on EC2 instances, both an AMD 64 and an ARM 64 instance. And
can I just ask you to zoom in a little bit here?
Yeah, I can zoom in. Oops, that's the wrong way. There we go. Nice. Cool. Yeah, so we're launching like those two EC2 instances that are building that build in parallel on native CPUs, and the results getting merged back. So you get like the same container image, but built significantly quicker and on native CPUs. We're able to like additionally show you some of this metadata about what happened, similar to the logs you would get, but you can go back in time and sort of analyze, like, okay, this particular step ran, like how long did it take? Why did it run? Why did the cache invalidate? Like questions like that. Nice. Cool. So that is on the container side. An interesting thing we are doing with containers, let me go to the list of builds here. So yeah, we started with containers here. We have a concept of a cache as well, a managed cache. So if you build a layer and then you run a build again, we've automatically persisted all of the result of that build and so we can reuse it and make the next build incremental. So
Mhm.
if I go to this build that I ran today.
And what would be the natural behavior or like the default behavior of GitHub Actions in this case?
Yeah, so by default, CI runners are usually ephemeral, right? So like when you get a new runner, there's nothing there. So either you don't have caching or you have to copy the cache from somewhere. And that copying of the cache from somewhere takes some amount of time. And depending on how large that cache is, like that time can potentially like be longer than the time the cache is saving you. So yeah, in this case, we're turning this into incremental, like similar to the experience of running this on your laptop. Hello, puppy.
Oh no! Oh well, actually, if we hear them, we want to
If we
see
hear
them. So
I don't know if I'm going to be able to see them.
that's
Hello,
okay.
puppy. Yeah, so similar to like your local dev experience, right? Where you like change some code, run a build, it's incremental. It doesn't have to like download gigabytes of content from somewhere.
And this is all managed for you, right? Whereas if you had to build this
Exactly.
from scratch, it means that you would have to like maybe index your file system layers. You would have to like manage them. I don't know, very close to the environment where you're actually building. So like this in itself, it's something that would take a lot of engineering effort, and especially for like serverless developers, I think I don't think serverless developers want to manage all of this sort of hassle, I guess.
Yeah, exactly. Like there's the like you don't want to set this up. Like this takes time to set up, right? You're wanting this build to run in a number of seconds. You're not wanting like an EC2 instance that's online all of the time. And then you're just not wanting to maintain this infrastructure long term, right? And like it's
Because I think
not your thing.
it's also really difficult to then match the local storage with the compute where it is. There's still there might be some like network latency in actually moving this data around. There are costs associated with it. So I guess that's a great nice to have that is going to deliver a lot of business value down the line, right, for your end customers. So that's really cool.
Yep.
So you said caching. This is I think it's a vital component in like shaving
Yes.
off all of the seconds of the build. Sounds
Yes. I
good.
think if you do want to compute something, you want to compute it as quickly as possible. The fastest thing to do is not to compute something, right? So if you can reuse a previous result of a previous build, then yes, that is the ideal. Yeah. So container builds, we started there. The platform we built, though, of like building things quickly and caching the result, making them incremental, all of that applies to more than just container builds, right? So we also launched an integration with GitHub Actions. So I have a similar diff here to show what was involved in the migration. So we have our unit test workflow here, and the runs on label, we added Depot to it. So we have similar labels. We also have ones for ARM with Graviton and with lots of different sizes of CPUs. So I think we see like here, we're saying, okay, this unit test job should use a Graviton instance and should have double the CPUs to make this particular build faster. So the cool thing that we do, like this is a pretty minimal change, but this routes this job to that like dedicated EC2 instance. We do a lot of automatic cache integrations. So like whatever you previously would have cached in your workflow, plus a lot of those other build tools like Gradle or Maven or Turborepo, whatever, we sort of auto configure those to store their cache in a similar system to the container builds. And let's see if yeah, cool. We have some fun observability UI as well. So similar to the container builds, you can go back and view the logs after the fact, but you can see things like CPU and memory usage over the course of that particular job and use that to like further optimize what types of runners you use.
I'm actually thinking it's really cool, especially when you have a lot of different Lambda functions that you need to build, and maybe you have different different packages, or like this maybe you're running on different kind of or runtimes. So I guess this is particularly useful. The actual question I had in mind. So you tossed that like almost like under your breath. All of these builds are actually happening onto a dedicated EC2 instance. So like I guess that's another additional interesting bit of why these are of why and how you're actually making it faster for everybody, but also even more secure. Because I know you folks, like for example, you work with the likes of pool sites, so like you have customers who are actually building for multi-tenant customers. So this is building on behalf of a lot of different customers that need to be segregated, right?
Yep. Yeah. So I'd say isolation is important for performance and security. So if you think about like building this yourself for your own company, right? You want like two different jobs that are running at the same time to not be able to slow each other down. You also want like, should one of those jobs be compromised in some way, like maybe a malicious dependency is installed, you don't want that job accessing other jobs that are running at the same time either. We as the provider of the service have that across every customer, right? Like each customer's individual job needs to be fully isolated, both from like the security standpoint of one customer or one job should not be able to influence another. And the performance aspect of like, we want these jobs to finish in as little time as possible. So they should have access to the resources to do that. So yeah, for the system, like every single GitHub Actions job, every container build is a dedicated EC2 instance that is used just for that job and then terminated. So yeah, we've
I guess that
interesting work into making that work,
yeah.
but that is the architecture.
Yeah, so a lot of servers in serverless, as we were saying before, but the end experience for you folks is actually serverless. You toss something onto your GitHub or your PR. You push it, and then that's all transparent to you. You guys are also building by the second, right? So there's I think there's a minimum like commitment amount, and I think for developers like around $20 a month, if I'm correct. But then you build by the second, so that's kind of gives you a sort of a, well, I would say serverless experience above a certain threshold. And I guess that I really want to dive deep into how you folks are actually making your EC2 instances start really fast. So I know that there's an interesting blog post that you put out I think a few months ago, but yeah, I guess can we dive deep there? Like what is it that makes booting up an EC2 instance so long, and like how do you solve that problem?
Yeah. So EC2 instances, they do certain things when they're first created and started, right? So like the particular hardware they're going to run on needs to be chosen, the networking needs to be set up, etc. Those things are actually reasonably fast. There's also an optimization that EC2 does to reduce boot time, where the content of the image, like the AMI being used for the EC2 instance, is lazily loaded onto the EBS volume. So like the moment you say, hey, I want to start this EC2 instance, then that sort of starts all of these processes, including like the sort of streaming of AMI content.
So this is
is
basically taking the golden image and like streaming it to the EBS volume, right? So this is a network operation that takes quite a while, and that's something that you want to optimize.
Yeah, so it means the instance starts somewhat reasonably quickly, but like as blocks are accessed, they are lazily loaded from S3. So if you're wanting to build a build, like you're wanting to start a whole like Ubuntu operating system quickly, and you want to like perform operations quickly in the build scripts themselves, right? Then that like streaming the network bits and particularly the like latency can slow things down. So what we ended up doing is a variant of like preloading that image onto EBS. So like you can imagine like starting an EC2 instance and accessing every particular block in the image. And then like that instance is fully like loaded into EBS effectively. That can be sort of slow. Like some of these CI runner images are like extremely large. I think there's in GitHub's image, there's about 80 gigabytes of software compilers. So yeah, so what we ended up doing is we actually create pools of instances that are booted and then have like the particular blocks that are needed for the job to start accessed and loaded, and then placed into like a stopped state. And so what this means is then when a job comes in, we can pick one of these instances that's been like effectively warmed and start that instance and give the job to that instance. And then this can cut like the overall boot time. Yeah, we have a nice blog post about this. Yeah, so this can cut the overall boot time, say like from 60 seconds down to 5. Like it can be pretty dramatic with that sort of targeted pre-warming. Yeah, we have a bunch of fun details on the blog.
Yeah, so you say so the first hurdle is we don't want to stream this. We don't want to stream all of the blocks from whatever the our golden AMI stores to the EBS volume. So that's kind of check, right? And then what else is there?
Yeah. Sorry, say that last part again.
I know, yeah. What's the next step? So like we've shaved off like by doing this, we're shaving off a few seconds by just saying, okay, we're not gonna stream. We have everything there already available onto that root EBS volume, right? What's the next step?
Yeah, so the EBS volume pre-warming does a lot for that like initial boot time. So that's the big cut from say 60 seconds down to say 5. Beyond that, you're talking about like operating system level.
Okay, so 80%
yes.
we get there by making sure that our EBS volume are warm. And by the way, we're not going to pay for this operation, right? I mean, we keep the EBS volume warm. They've been cloned from the golden AMI, but then you shut down the instance, right?
So the instance is in a stop state. EC2 has an interesting feature for modifying instance attributes that are like for instances that are in a stop state. So this means we can actually create like a pool of these instances for a given AMI image. But then when the user like says, hey, I want 8 CPUs, we can actually pick the instance type and start the instance. So sort of an optimization on our side that's sort of invisible to our customers. But yeah. So the instance starts quickly. We do interesting things in the OS, like obviously like not starting things that aren't needed is an easy optimization. But I think we've gone like even down into, let's have a custom block driver for the disk itself so that we can cache like disk IO operations in RAM before they hit the disk. So you start to get like sort of really specialized optimizations for the access patterns of CI workloads.
Well, that's so I'm thinking like what kind of research are you guys doing to actually get to this point? So and also like what maybe a question about like how your team is built, like what kind of engineers do you have on your team, and what kind of research space do you explore?
Yeah, so research space, I think we measure things like job start time because our customers do, right? Like the time it takes to start a job is the time you wait for a build to start. And then also we have a very clear like, oh, this job took an hour on a default GitHub runner. On Depot it is taking 30 minutes. So we can sort of measure both of these, like queue time and speed up effectively. So when we hit a bottleneck on that, then we sort of like debug that, I guess, which is where you get into like all of the different levels of optimization that we've done have been the result of, okay, it is taking this much time. Where can we find a way to shave off additional time, right? So yeah, I don't know. Team-wise, we are, I think we're 12 people now. We are fully remote. So we have people all over both North America and Europe. So we're growing. I think last year we were about half that size.
Wow.
But yeah, we are currently hiring. So if anyone would like to check out the careers page.
Yeah, I'll be sharing the link in a few seconds, folks. But yeah, folks, in the chat, just let us know if you are looking for a remote job. There, I think Depot might be a very good fit if you're really interested into shaving off those kind of hurdles to having performant builds. Sorry, but I guess that I think you folks are also like expanding the range of where fast and available compute actually can make a difference. And so I'm thinking mostly of the one of the latest announcements that you folks have published, that you are going to provide, or you're already providing, sorry, remote agent sandboxes for Cloud Code.
Mm-hmm.
How does that work, and why would you need like some additional I don't know, caching or like performance there?
Yep. Nice. Yeah. So I think a lot of what we built, or maybe all of what we built actually, has come out of like our own use case for using it or customer use case for using it. So if you're not familiar, Anthropic released a tool called Cloud Code. And they also released a way to run Cloud Code in a GitHub action. So our existing customers who are adopting Cloud Code and were using us as a GitHub Actions platform began like adopting the two together, right? Because not only would they get the like agent experience, but they would get the accelerated build compute and default caching that we're providing in GitHub Actions. However, not everything you want to do with a code agent involves a GitHub Actions workflow, right? So maybe you want to, whatever you are running on your laptop, you'd like to spawn a couple of different agents in parallel to work on the same thing. Or you want to write like a Slack integration or a Discord bot or something like that. So we were watching our current customers kind of like hack around this use case of like, how do I figure out a way to use the Depot compute and the agent together? And we sort of built a tool that merges the two and doesn't require GitHub Actions, I guess you could say. So yeah, we do have a blog post. I think our release is pretty early. I think this is just the first step towards this, but we have in similar to Docker fashion, we have a Depot Cloud command that accepts the same arguments as the Cloud CLI, but runs that in the Depot compute platform. So I don't know, I think of this more today as a composable tool or an API of like, if you're using the Cloud Code CLI and you want a place to run it remotely in a sandbox, then we have a way to do that. I'm interested to explore other like surfaces on top of that, but yeah, I don't know if that covers what we're.
Yeah, absolutely. No, again, I'll be sharing that as well in a few seconds. And so I guess is also I'm thinking, what is the relationship with like having the possibility of like just swarming agents on your platform? But that's I don't know. Do you have customers that have been doing this? Like, do you see do you see a lot of your customers actually migrating, or not migrating, but maybe adding on top of their build also this sort of agentic workflow? And this is the kind of a I don't know, the startup part of myself that's really interested in this.
Yeah, it is a very interesting space, and people are, I think, continuously discovering new interesting workflows. So yeah, we have seen our customers doing very interesting things. I think like the ability, like for a CI failure, like the ability to throw that at an agent before, like, and maybe it's not perfect, right? But if it catches some of them, right, you can be like, hey, this CI failed. Can you go look at why? And if you can figure out why, can you open a PR? Or like I have these tasks in my backlog that I'm never going to get to. Let's just fire off the agent at them and see how far they can get. And it's getting to the point that is pretty productive at this point. So I think I'm curious where the swarm part of it will go, right? Like the more of them you have, the more, I guess, burden on management and review goes up. And so I think there are interesting like product UX type of challenges in that space to be solved.
Yeah. No, I absolutely agree there, and I don't know, Chad, if you agree, or what is your experience with like this sort of like swarm tools that can build in parallel on many different tasks? Because I've tested some of them, or like maybe I wrote some of them with Strands, for example, and the kind of like the I don't know, the amount of context that I need to load into my brain actually to make it work for me. Sometimes it's really hard, and I'm super curious to learn what you folks what your experience is with agentic swarm and agentic coding. I kind of call it, like, I don't know if you're familiar with the concept of like Monte Carlo coding, because it's like, oh, just like, tossing everything that may work, and like we have some back and forth on the on my GitHub repo, and maybe something's gonna work, something that's not gonna work. But that's good fun. But with quicker and more performing startup time, I guess that would be something that the one we want to explore. And I guess for you can consume Depot in a couple of different ways from what I understood. So your normal subscription plan is offloading all of the build onto your own AWS accounts, right? But then you guys are part of the Amazon partner network, so APN, or you also have an offering on the marketplace. So how does that work?
Yeah. So all of the compute and control plane on our end is in Amazon. And we have a way to connect for that compute and cache plane. We have a way to connect to another AWS account, right? So I think we have a lot of customers who just use us in the kind of serverless, I don't care where it's running type of way, like just make my builds faster. We have a subset of customers who are like, I would say AWS native. We still run the compute, but we're very integrated into the AWS system, so they can be in the regions that they would like or communicate with the services that they need. And then I guess the ultimate form of that is we have a way of orchestrating compute in another AWS account. Yeah, I don't know, marketplace we can use with any of these different offerings as a way to procure Depot.
And so the control plane stays in your AWS account, and then you remotely spawn instances, and you adopt the same type of optimization, right? The ones that we mentioned. So pre-streaming, EBS. I think in your article you also mentioned worm pools. Are you guys still using that?
Yeah, those are those pools of instances that have been prepared, I guess, for those jobs. So yeah, and we can in the deploy into your own compute space, we can also have pools of like GPU instances, for instance. Like some of those customers have, say, GPU reservations with Amazon and would like to use them for CI. So yeah, we can sort of have pools of different instance types or machine images, depending on the particular need.
And you would configure this into the GitHub action flow, right?
Exactly. Yeah, it ends up
Okay.
just being like a one-line YAML change your runs on type of thing.
So there's the type of workloads that you can actually build is very wide, right? So I was thinking, especially when I'm building Lambda functions that have a JavaScript runtime, and maybe I have to do like the cross build for ARM or for x86. I guess that, the management of all of the package that I need to down from npm, that's a headache in itself. And the same for Python, I guess, for the same type of runtime. But I'm talking about front end. But I guess that there are other challenges that are connected maybe to the build out of machine learning models. Do you folks also deal with that?
We do deal with that. So machine learning models are incredibly large, and I would say, like we have a lot of customers who are either using them in a CI workflow or especially packaging ML or AI models into a container image. And there are particular challenges there just due to the sheer size of those files. Like most CI platforms, or for that matter, even the container image format, I don't think we're anticipating that much data to be moved around. So our architecture is particularly suited for that, being in Amazon. Like we can copy like cache restores or container build outputs and all of that are over the private network, right? So like significantly higher throughput than, say, a public CI runner. But we've also done some work, say, on the container side to support some of the like image format optimizations. So eStarGZ is one, or Nidus is another, that kind of provide a way to stream containers, right? So like you want to run this really large container with a very large ML model in it. You don't want to wait 5 minutes for that model to download. You want the container to start up and begin responding to requests. And some of these like additions to the container image format let the container sort of lazy load content after starting. So yeah, our container build platform fully supports that. We have a lot of customers with AI ML workloads that are using that sort of thing.
Right, that's really, 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 really cool. A question I had on models. I didn't know if you've seen a lot of like variability on the actual blocks. Because I'm thinking like when, especially if you think about large language models or something like that, like there are going to be a lot of changes, even in fine tuning. I guess on random places in the I guess on the file system, like what is distributed. Like, have you ever seen a kind of workload like that?
Yeah, I don't know that we've seen that kind of workload. I do know that from my experience, like ML model weights do not compress as well as, say, a text file. I think that makes sense. I think most of the work people do around this is kind of that streaming index of sorts, so that you can take parts of the container system and lazy load them. But that's kind of after you've got the ML weights. I think we're less on, say, the training or fine tuning side than other.
That sounds cool. Yep, sounds cool. And I have a question from Schizophrenic Web Developer. Hey, I think I saw you on another stream I did this morning, but are there any plans for you to switch from TOML to JSON C? And JSON C is the JSON with comments, right? Thanks for that question, Schizophrenic Web Developer.
I don't know what we are doing with TOML, so I'm not sure.
So it says it was referring to like a configuration file. So I don't know, maybe.
Yeah, we generally have
I don't know.
no
Schizophrenic web developer, let us know what actually you meant with that question. It got us both confused. I don't know if it's a challenge that you're that you've decided to to get on. But yeah, if it was a challenge, you definitely got us there. And yeah, no. The other question I actually had, it's about like a serverless, the serverless usage, because and like pay as you go kind of model.
Mhm.
So I was thinking about like the network topology, and so when you're actually building on behalf of your customers. So is there how does like the data transfer work there? Because I'm when I work with my customers, and again, this might be a super selfish question, but when I work with my customers, we do have a lot of concerns about data transfer out. So is there any data moving from one account to the other across the web, something that we want to avoid?
Yep. Yes, that is a good question. And so this is also a challenge for us, especially container images, right? Those are multi-gigabyte files. Yeah, today we do not charge for any network transfer, and we just kind of try to architect around it on our end. So things like layer cache, for instance, are local, right? So from the EC2 instance that's processing the build to the cache system is over the like in region private network. So there's no charge for us for that data transfer. I think interestingly, cache hits have a benefit for data transfer out, right? Because the more the content you built is already in your registry, the less you need to copy.
Mm-hmm.
So being in Amazon helps, right? So like if we're pushing to a customer's ECR repository and it's in the same region, then cool, that works. There's also, I guess, networking wise, a performance angle here too. So for say a GitHub Actions runner in GitHub, my understanding is there's about a gigabit per second of throughput to the public internet. This is just what they've decided to offer. In our case, we actually launch the EC2 instances in public subnets with public IP addresses. So the instances get the full like 6 gigabit throughput to the public internet. They also get their own dedicated public IP address. So for third-party services, like maybe you need to access an API or pull a container, this also means you're not sharing like IP-based rate limits with other customers or other jobs. So all of this kind of adds up to let's make your network access reliable and performant, and yeah, for whatever the job needs to do.
Oh wow, that's great insights there. And folks, we are getting closer to the end of the stream, but I just wanted to reiterate that what an awesome company Depot.Dev is. I've been working with them for the last past month, and the kind of technical challenges that I've seen there are absolutely mind blowing. So I need to rely on a lot of other solutions architects to actually help me get there, especially when it comes to networking. It's not definitely my forte, but I know that if you're in that you folks are super interested in challenges like that. So Depot.Dev is hiring, and you can get in touch at the link that we have shared on Twitch. I will be sharing it soon on YouTube as well. So folks, I wanted to first of all thank Jacob for sticking with us for today. It's been an absolute pleasure as always to have you on stream and discuss with us how to make this build faster and how to deliver exceptional serverless experiences for your end customers and folks around Twitch and around YouTube. I wanted to thank you for sticking around. This has been the Serverless Office Hours. We will be back next week, same time, same channels. And again, thank you for sticking around and for all your questions. And I'll see you next week. Bye bye.